Hi, this is Ginny de Villiers, and I'll be presenting the stats. The stats I've divided up into seven sections. So this is the first of the seven, and this is permutations and combinations. Okay, so with permutations and combinations, I think when you look at the question, you need to decide if it is one person choosing a space or if there's more than one person choosing a space. Or so if there's one person that wants to take a seat in a cinema and there are 10 seats available, they've then got 10 options. Okay, so there's no need for factorial. So how many ways can one person sit in an 8-seater bus would be 8 ways. So in that way, how many ways can two people sit in an 8-seater minibus? The first person actually has 8 options, and the second person has 7 options. So that would be 8 times by 7. You could also say 8p2, but 8 times by 7 is perfect. If you are arranging then a certain amount of people in a certain amount of spaces, so then you use factorial notation. So that is if you've got 10 people, 10 spaces, 10 factorial. So 10 letters, how many ways can you arrange all of them? 10 factorial. So it's same number with same number. So how many ways can I arrange 8 people in an 8-seater minibus would be 8 factorial. Okay, if you then are picking a smaller amount from a larger amount, then you need to decide whether you're going to use NCR or NPR or both. Okay, NCR is obviously when order does not matter. In other words, we're just choosing, and NPR is basically we choosing and we're arranging. All right, so that would be NPR. So how many ways can I pick 6 people from 10? Would be 10C6. No issues. If you are then arranging them, so the ordered counts, then you use NPR. So how many ways can I choose? 6 from 10 and then arrange them. All right, you could look at 2 options here. You could go, okay, I'm choosing 10C6 and then I'm arranging them. So times by 6 factorial. That is exactly the same as if I went 10p6, and that's 10 arrange 6. And both of these options, this can sort of come in handy if the numbers start to change, and I'll show you an example. So if I have something simple, how many ways can I arrange with 3 letters from 7 would clearly be 7p3. But if I had something that like this, so a group of teenagers consists of 2 girls and 4 boys. How many ways can I arrange them if a group of 5 is chosen, but both girls have to be in the group already? All right. So what are they saying is they're saying 2 of the girls are already there. How many ways can I choose another 3? And then I want to arrange all of them. Okay. So in this case here, I would be picking the 3 boys would be for combination 3 because I'm choosing them. I can't go for P3 because I'm not arranging 3, I'm arranging 5 of them. So that would be for choose 3, and then I times by my 5 factorial, and that is arrange all 5 of them. Okay, so that if you need to separate them, that is more than it's possible. Okay, so let's look at one big example. 8 people sit in a minibus, 4 on the sunny side and 4 on the shady side. If 2 people want to sit on opposite sides to each other and another 2 people want to sit on the shady side, in how many ways can this be done? Okay, so when you get something like this, just sort of picture people coming up to the taxi and going, okay, well, what are my first options? All right, so I've just drawn the sort of 8 seats here so that you can have an idea. All right, so the first 2 people want to sit on either side. So the first person actually has a choice of 8. Okay, so the 8 is the first person. The second then person is obviously wants to sit on the opposite side of that person. So, which they've only got an option of 4 because if that person chose this, then they've got an option of 4 here. So that's the second person. The third and the fourth person want to sit on the shady side. Now, the shady side, whichever side it is, has got 3 spots left. And we want to arrange 2 of them. So that would be 3 arrange 2. Or you could write 3 times by 2. But that's the third and the fourth person. And then the last 4 people sit anywhere. And there are 4 spaces left. There are 4 people. So it's 4 factorial. So if you break down the question, you can get something that's quite complicated. You can make quite easy. Okay, so this type of question is asked quite often these days. Find the number of ways of arranging 6 women and 3 men in a row so that no 2 men are standing next to one another. Okay, so no men, out of the 3 men, no men are allowed to stand next to each other. So the trick with this question is if they've asked for no men next to one another, you go to the woman and you separate the woman and you put a spot where a man can go. So I've got the 6 women here, and then my red arrow is every spot that a man could go there. All right. So there's 7. There are 1, 2, 3, 4, 5, 6, 7 slots for spaces that we will need to fill with 3 men. Okay. So that would then be 7 arrange 3 and then times by 6 factorial, which is the 6 woman, because the 6 woman can be arranged. So this 7p3 is 7 spaces, arrange 3. Another way of looking at it would have been, okay, your 6 factorial, which is the men, times by, and if we look at the first man has got 7 options of where he can sit. The next man has got 6 options, and then the last man has got 5 options. So that is exactly the same as that. Okay, then you get where they ask us probability. So they could ask us the probability of a permutation, or they could ask us the probability of combinations, which is what we call hypergeometric. Okay, probability of permutations is quite simple. Let me show you. So here's an example. Baby Thomas has a set of alphabet blocks. His mother often uses the blocks THOMAS to spell Thomas's name. One day she leaves him playing with these 6 blocks. When she comes back into the room, Thomas has placed them in the correct order to spell his name. What is the probability of Thomas placing the blocks in this order? So he's 18 months old, so he definitely cannot spell. All right, so the mom's obviously quite proud, but what is the probability that this could possibly happen? And remember that when you're looking at probability, it's over your sample space, and your sample space is all the possible options. So the sample space is how many ways can this be done, which is 6 factorial, because he's got 6 blocks, and it would be putting 6, those are the possible options that you could have. How many options does he have to get it right would clearly be 1 option. So the probability would be 1 out of 6 factorial. So the second example is a couple of days later, she leaves Thomas with all the 26 of the blocks. When she comes back into the room, she again sees that he has placed the 6 blocks in the correct order to spell his name. She was probably quite shocked. What is the probability of him choosing the correct 6 blocks as well as placing them in the correct order? So now, obviously, Thomas needed to have, out of the 26 blocks, he needed to actually have picked the 26 and put them in the correct order. So that clearly the sample space would be 26 arrange 6. And how many ways could he possibly get it right? There's only 1 possible option. Okay. Then you get probability of combinations, which is just simply our hypergeometric. And hopefully you've been exposed to lots of this. So a school maths team consists of 5 candidates. There are 6 boys and 8 girls who are available that week. What is the probability that in the team of 5, there will be more girls than boys? Okay, so in the team of 5, we're obviously looking at the sample space would be 14 choose 5, and we're looking at more girls than boys. We would go, okay, cool, 3 girls and 2 boys, or 4 girls and 1 boy, or 5 girls and no boys. And this is sort of asked year after year, and it's a great question. Just remember that obviously you will need to unless there states that you don't need to, but you will have to put this all into your calculator to come out with an answer. And it takes a lot of time doing this on your calculator. So my suggestion is finish the paper and then go back if you've still got time to do the calculator work, because you don't want to miss out on a whole question for 10 marks because you spent time punching stuff into your calculator. Right, question 2. If they give us some proviso, so find the number of ways of choosing the team of 5 if 3 of the boys are cousins and are either all in the team or all not in the team. And this is where if you've got or in hypergeometric or in combinations is your best friend, because or means you're just going to add all your different options. All right. So in this first case, you could either say, all right, so the cousins are in. All right, so that means 3 of them are in, which means from there are 11 left, and I need to choose 2 of them. Or you go, okay, cool, the cousins are out. So that means I'm still choosing from 11, but now I'm choosing 5 different candidates from the 11. And that's as simple as that. Okay, this last question I've done is is from last year. And it's just quite a nice question. And a lot of the candidates struggled with this question last year. So, how many ways can the letters of the word ceaseless be arranged? This is quite simple. Both of these questions could easily be asked in your paper 1. All right. So, ceaseless. So how many ways can it be arranged? Would clearly be your 9 factorial over your repetition. Okay. So. The next question is, find the number of different ways in which the 9 letters of the word ceaseless can be arranged if exactly 2 of the E's are next to each other. Now, that's quite specific. So it's not, you're not going to go total minus them or put them together, because the problem with it is exactly 2 E's are together, there are 3 E's. So in a way, you need to work out that only 2 E's are together and the 1 E is not with it. All right. So this type of question, again, is like the woman and the men's question. What the best option is to have a look at where the E's could go. So if I had to rewrite this as CASSOS, okay, these are all the possible options left over. So I've got 1, 2, 3, 4, 5, 6, 7 spots left. All right. Now, in those 7 spots, I need to put a double E and a single E. So they actually are different. Double E, you could even call a different letter, and single E, you could call a different letter. All right. So I've got 7 slots. So what it would be is I could go the first. So what I've done over here is this is the CASSLS, which is 6 factorial divided by my repetition, 3 factorial, times by 7 options for the double E, and then 6 options for the single E. So whichever the 7 has gone into, there are 6 options left. Or if you're good with your language, you're going, okay, cool, I've got 7 slots and I need to arrange 2. The 2 things that I'm arranging are a double E and a single E. So it will be 7p2 times by my leftovers 6 factorial divided by my 3 factorial. Okay, I hope you learned something, but you need to practice this section as much as possible. And I've put a lot of practice into the worksheets that you guys can have a look at. But good luck.